All right, here we go. So now we've already done A and B. Now we're going to do part C. It says block 3 of mass M3 is added to the system. So that's this block right here. Does everybody see that on your paper? As shown below. There is no friction between block 3 and the table. All right, so indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as in the original 2-block system. Explain how you arrived at your answer. What do you think?
Well, let me see.
I think it will be smaller.
Okay. Think it'll be smaller?
Yeah.
Do you have a reason why?
Because now that's more mass between
Okay.
the other side.
It doesn't
I think it'll
have
be
any
larger.
force because there's no friction, so there's not going to be force in any direction.
Okay. So you're saying,
I'm saying the same.
Same?
It's the point
All right.
saying
where you leave the table on.
okay, and
Once out.
thank
starts
you.
moving.
Appreciate that.
Oh, I'm sorry.
No, go ahead. I'm being serious.
Okay.
Now we have
Are you sure?
There was an ant. There's an ant crawling away from your
Because once you get it,
Right by me
well,
here.
nah, never mind. There's a pulley in the way of my idea.
Yeah, it'll stop once it hits the pulley.
Yeah!
which one
It works better with Sharpie.
Wait, you need a red pen and then I can't do it. Why does that work? What the heck?
You're drawing to me.
Wait, you need to block them Mr. Barry, why does this work?
Oh, when forced, he
don't
will
have
cross
enough.
the line.
All right, so that was our fun for today.
Mr. Barry, why does that work?
I think the ink has a smell.
You saw it.
All right, so here we go.
That was recorded.
Okay, so I've had one person say smaller, one person say the same, one person say larger. Nope, I'm just kidding, but maybe larger.
Yeah, maybe.
So, but the bottom line is
We don't know.
we really don't know just by looking at it. And as you do more of these problems, you will gain the experience and you'll know. But what I suggest is work it out and see what it is. So, and it's a good example for us because this has 3 different objects on them. And so let's draw free body diagrams. So for block 1, all right, block 1 has gravity, so that's M1 times G, mass times gravity, and it has tension. And I'm going to call this one T1. I'm going to do block 2 over here where it's located. That one has same force of gravity, M2 times G. And it has tension, and this one I'm going to call T2 because it's a different rope, right? All right, so that's a different rope. Just do the other one. There you go. Is that better?
Is the white and thingy still not working?
I don't like the ambiance.
They're on.
Whoa. Can we turn them both off then?
Yeah, you try it if you can see.
Great.
Maybe move them a little closer?
There we go. Enough talking.
Is that better?
Yeah.
Let's do it.
Well, vampire.
Can you read here?
All right. Yes. Okay, so here we go. So there's block 2. Are there any questions on block 2?
No.
Block 3. And it says that there is no friction. Block 3 has force of gravity, M3 times G. Normal. T2. T1. All right, so now The next step in all of these, the process, is to sum the forces. So I don't have anything in the x direction here on block 1. So sum of forces in the y is T1 minus M1g is equal to mass times acceleration. And it's M1 times acceleration. In which direction do you think it's going? I think this M2 is driving everything. So I think the acceleration is upward here, so I'm going to leave it as positive. Sum of forces in the y on this one is normal minus M3g equals, is it moving in the y direction, block 3? It's sitting on that table, so no. Sum of forces in the x direction, T2 is going to the right, which is positive. T1 is going to the left, which is negative. And that's equal to M3A. And which direction do you think it's being pulled? Positive direction. Block 2 has nothing in the x. So sum of forces in the y, T2 minus M2G equals M2 times A. And which direction do we think this one's going? Down. Put a little, looks like a 3 equal sign, but that's a negative. Okay, so now I have A, which is unknown. I have this A, which is unknown, and this A, which is unknown. They're all stuck together with a rope, so what are those? They're all the same A, right? They're all moving at the same rate, acceleration. I have T1 and I have T2. So I have A, which is an unknown, T1, which is an unknown, T2, which is an unknown. I have 3 unknowns, 3 equations. This one doesn't do anything for me here. Okay, but it would do something for me if I had friction. All right, so here's what we're going to do. I'm going to take T1 and I want to set this. I want this to be M1 times A plus M1 times G. So that's what T1 is equal to. T2 is equal to M2G minus M2A. Now I'm going to take T2, which is this. I'm going to plug it in right here. I'm going to take T1, which is this, and I'm going to plug it in right there. And what I'm going to have is only A as the unknown. Because remember, G is the known. We know what that is. M1 and M2 and M3 are all knowns. So it'll eliminate the T's, and I'll be stuck with A. So T2, M2G minus M2A minus T1. So that's going to be minus, I'm going to put it in parentheses, M1A plus M1G. And that all equals M3A. All right, so that negative needs to get distributed to both of these, is what that's saying. Both of them. Can y'all see that? Okay. Now what I want to do, I'm solving for A. So I want to get all of my A's together. So what I'm going to do is I'm going to send this and this over here. Okay, I'm going to do that by adding M2A to both sides and adding M1A to both sides. So what that ends up looking like is M2G minus M1G is equal to M1A plus M2A plus M3A. Factor out a G to this side, that's M2 minus M1. is equal to, factor out an A on this side is M1 plus M2 plus M3. Got to get A by itself, right? Divide both sides by M1, M2 plus M3. So A, I'm going to write it right over here. A ends up equaling G times M1, or I'm sorry, M2 minus M1 over M1 plus M2 plus M3. All right, so just to remind you so that you don't have to go flip to the next page, this is our answer. What it was before was A is equal to G times M2 minus M1 over M1 plus M2. So, which is it? Why?
Because there's more on the bottom that you're having to divide by.
The denominator is bigger, which is going to make it smaller. You're dividing by a bigger number.
Oh, I was right.
So smaller. Okay.
I was wrong.
Working it out makes it where you don't have to think through. You remember when I said, sometimes you can figure this stuff out, but there's going to be problems where you look at it and you're like, I think it's this, but I'm really not sure. This is what I mean. So work it all out. All right, any questions?
Okay, so which force was it that N3 added?
It increased the mass of the entire system is what it is.